Welcome back. The objectives of this video are to study average rate of change and the secant line, and then average rate of change and concavity. So in previous video, we looked at the average rate of change and talked about it's really trying to figure out the rate of change along a curve. And we found different representations with graphs and tables and things. Here's an example of a curve in which we have a secant line passing through two particular points. So the secant line is a line that joins 2 points on a function. And we want to find the slope of the secant line through those 2 points, and that'll give us our average rate of change over a particular interval from, in this case, from A to B. So we see here our average rate of change just from the previous video is our change in y over our change in x. And if we have a secant line through those 2 points, we can find the slope of that line. And our y values are f of b, so put b into the function, find the y value for a, and b minus a. So essentially our change in y over our change in x. In example 1, we want to consider the graph here at the right. And this particular graph passes through the points 0, -3, and 4, 3. It also passes through 2, 0, the x and y intercepts. Explain how we know its equation is y equals 3/2 x minus 3. Well, the minus 3 actually is pretty easy. 0, -3 is our y-intercept, and this format is in y equals mx plus b. So the y-intercept is -3. Our slope is 3/2, our m is 3/2. Well, we can figure that out. That's our rate of change. Our slope is 3 minus a minus 3 all over 4 minus 0, or 6 over 4, which is 3/2. So our slope is 3/2. Our y-intercept is 0, -3. And this is in the form y equals mx plus b. Question B, what do you notice about the average rate of change for the linear function? It is constant. The average rate of change is constant. It is the same. It is 3/2 no matter where or which points we choose on there. How is the average rate of change related to the equation itself? They're really asking us to define the slope, and they're saying for every change in x of 1 unit, then the change in y is a positive 3/2. Question D says, use the grid at the right to sketch a graph of the function that represents the average rates of change of the linear function. Well, remember, our average rates of change in a linear function, hint, consider your answer in part B, is constant. It's always the same. It's 3/2. So our function here for our rate of change is y equals 3/2. So that would be a graph that looks something like that. In example 2, we're given a quadratic function of x squared minus 6x plus 5. They've graphed it for us here at the right. And it says, use the table of values to find the average rate of change on consecutive equal length intervals of x values. Record your results in the table. Well, average rates of change is slope, and our slope is going to be our change in y over our change in x. Well, our x's are these intervals from 0 to 1, 1 to 2, and 2 to 3. So fortunately for us, our change in x is always 1. So the denominator of these is 1. And our change in y, well, we just have to look at this. So we're going 0 minus 5. So the average rate of change from 0 to 1 is negative 5. And negative 3 minus 0 is negative 3. And negative 4 minus a minus 3, I'm looking at the interval from 2 to 3. Negative 4 minus a minus 3 is negative 1 over 1. And then from 3 to 4, we'll do negative 3 minus a minus 4. That's going to be positive 1 over 1. And 4 to 5 is 3 over 1. And 6 to 5 is 5 over 1. So we have our change in y all over our change in x, so our average rates of change in these intervals. This is constantly changing. In fact, it's constantly changing by 2. So our change in our average rate of change is a positive 2 for each one of these intervals. Using the results from the table of average rates of change above, do you notice a pattern in the rates of change? What can you say about the rate of change at x equals 3? Well, as the intervals move to the right, the rates of change increase by 2. So as we move to the right, the average rates of change increase by 2. At x equals 3, what can we say about our average rate of change? Well, x equals 3 is the point they've plotted for you. It looks like that's where our graph has an inflection point, and the average rate of change, remember, that's the slope or the slope of the line. Well, the slope of the line at 3 is 0. So our average rate of change is 0. It's a horizontal line. Over any length input value interval, the average rate of change for a linear function is constant. That is constant. The average rate of change for a linear function is constant. Given consecutive equal length input value intervals, the average rate of change of a quadratic function is given by a linear function. That's why these differences were all the same. And the average rate of change over a closed interval a to b is the slope of the what line? The only thing we've studied so far is the secant line. In sample 3, we're going to look at the average rate of change in concavity. So in the quadratic function, we can determine the curvature or concavity of the graph by considering the average rate of change over equal lengths x intervals. Sketch secant lines on the graphs to show. So here are some secant lines that I'll sketch in red. We'll choose those 2 points. We've got a secant line there. And this is a little bit tougher. We'll do a secant line through those points. Looks like I missed by a little bit. We'll fix that guy. That's going to be a secant line through those 2 points. And this next secant line is going to look a lot like the previous one, but we'll do our best to go through those 2 points. And you can see here that the slopes of each of those lines, those secant lines, is changing. The slope is increasing. They're becoming more and more positive. So that's concave up. And then in our concave down, our secant lines, again, are changing. But those are becoming more and more negative. So that slope is decreasing. So the slope is decreasing. That's a characteristic of concave down. And we'll get some more practice with this when I see you in class.